Hello, my professor. I hope you're doing great. My name is Salat Ismail, and also one of my teammates, Abdurrahman Saeed. Uh, Today, I'm going to present. We've completed our project, so I wanted to say something like how we build the project, what we use it, which notice, the reason, and something like that. So for that, we are software engineering students, and today we are excited to present our machine learning project titled. The title of the project it was Mental Health Risk Prediction using a name. We used this software. We didn't use it anything about like IBMSs or Python. We selected this one. So in this presentation, we will show you how we processed our data, built different models, and evaluated their performance to predict a potential mental health risks among individuals. The project overview. The main goal of our project was to predict a mental health risk using machine learning techniques. We used a dataset that contains several important features like age, gender, GPA, sleep hours, study hours, social habits, and internet usage. Our tools of choice was NAME, our graphical data analytics platform that allows easy drag and drop workflows without needing to code everything manually. NAME helped us building our pipeline from data processing to model training and evaluation step by step. The problem is relevant because early prediction of mental health issues can lead to early support of intervention. Data pre-processing. We started by loading the dataset using the CSF reader node. Then we cleaned prepared data using column filter. Missing value node to handle incomplete data. Row filter to select row filter to select important subsets, and rule engine to define a new target label for mental health risk. Domain calculator. This one to prepare metadata for downstream analysis. We also explored the data with a table view. That one verifying the value distribution and checking for consistency. Every pre-processing steps ensured our data was clean and well structured before handling. Feature engineering. In this phase, we made our sure our data sets meaning and balanced features. We transformed categorical values if needed, examined domain distributions, and stratified the data using the partition node. This made sure that both classes mental risk PC nor risky were balanced during training and testing. This was important to prevent bias in our classification models and also the modeling path. We applied the supervised classification techniques using two models, decision tree learner, uh, random forest classifier. We used the following name notice, decision tree learner, and random forest learner and predict to test a partitioned dataset. Score to evaluate a prediction. Score to evaluate the prediction. The model were evaluated based on accuracy, how many predictions were correct. Also, precision is how many positive predictions were actually correct. Recall how many actual positive cases were identified. Confusion matrix. For visual evaluation, we tested each model with the same partitioned data to ensure a fair comparison. Model comparison and visualization. This notice we used the model comparison and visualization to compare both models. We used a joiner order to merge result. Math formula code to extract numeric matrix. And also this one group node to summarize class interval and overall statistics. Bar chart to visualize precision, recall, and accuracy. We then looked at the difference random forest performed slightly better overall. It had a higher precision and recall in identifying mental health risk. Decision tree was a simpler and interpretable. We also trained a manual calculate some matrices when notice didn't give us a complete overall scores, which gave us a deeper understanding. The final charts clearly show that the better performing models. Final thoughts and learns. This project helped us to learn how to prepare real world data, building models in a low code environment, evaluate and interpret classification metrics, compare machine learning and using a visual tools. Now made this a learning process smoother and more visuals. The project also gave us the insight into how data science can be applied to important social problems like mental health. In a summary, we discussed these three random forests in an aim to predict mental health risk. We evaluated both models using standard metrics, visualized the results, and learned valuable skills in a data analysis, machine learning, and reporting. Thank you for watching our video. We hope we found it informative, inshallah. So, we can try how it's like when we run the project seems like this. Every node when we run, it's like we don't have any like error. So also this is the column filter. If we see just this like see what we need to see it here. I think we don't need much. This one classified data, yeah. And this bar chart, it shows the group it's classified for female and female. Then it gives us like when we click one of it, the color is changed. So it's okay. This one also, this one the prediction, the output. We use this evaluations after the scores in order to compare the results, and that's the table view. So if we say, let's just say when the result is okay, scorers. So although we don't have a much time, like more than 10 minutes, I will close here. Thank you for your helping and watching my video. I hope you good grade.